Okay, so guys, I got this book. It's on flight mechanics, theory of flight paths. Trying to just learn about how to design the thing in such a way that it goes in a straight line. We're trying to get the longest distance in a straight line. Yes. Okay, so did anybody by any chance work on design over the week? Any ideas? No. I know Kamal said he printed out a 20-page calculation from a university somewhere. I think it was Olivet.
20 pages?
Yeah, of calculations and stuff. And they also said there's an institute of aerospace engineering somewhere not too far from it, in the suburbs or something. So those are the two things that Kamal told me yesterday. So I feel that would be very helpful. But so, did you come up with anything, your calculations?
Yeah, I did, but everything just still depends on the materials. As I have to get the the rubber constant. I have to know the weight of the wood we're going to get and everything like that. So I think my calculations right. Because I'm trying to equate everything with the equations of motion. So, okay, according to what I saw, the longest distance is 183 inches.
183 inches in the straight line.
Yeah, so if I'm going to make something like 190 inches, I need to.
How many?
I'll make something like 190.
So you work backwards. You work that, okay, you want to make 190 inches. Then the other thing is you want to be sure of certain parameters. So what type of parameters you need?
I need the spring constant.
How would you
The rubber constant, sorry.
Rubber constants, yes.
How would you do rubber?
How you do it? Because if you need help, because these are things we need to get done, sharply.
I'll need, right? Then the wings, from based on what I did, there should be an angle of between 5 degrees and 15 degrees from between the wings and the horizontal. There should be an angle that should be maintained, and then the wings have to be shaped to about 2 degrees so that it's able to take off.
So 5 to 15 degrees.
Alright.
That's what he said.
Then there's something else that's 2 degrees so that the plane, so the wings, so the plane, the glider can take off, right? How it works is this: as it moves, right? Because it's the angle, the thing is raised 5 to 15 degrees above, and then tilted 2 degrees down. That kind of thing. As the air hits the wings, right? It causes an area of high pressure and an area of low pressure. Now when that happens, air is forced to move. Now, as the air is forced to move, it picks up the glider and moves with it. And that's how the glider glides and moves up. Now, if there's no weight that balances it will spin around.
Then it falls, then it crashes.
Exactly. Now, that's what we need to do. Exactly.
I know our distance is supposed to be in a straight line. That's another thing to consider.
Yeah. And that's what it's supposed to be straight, and that's why they didn't talk about, if it was supposed to be a straight line, right, then we have to have some kind of mechanical thing that enables it to bank to the right and bank to the left.
That's how we need to.
True.
No, but that's the thing is, we're not banking anyway.
Yeah, we're not banking.
You can staple.
And okay, one of the.
But that's the point I was trying to make, though. What we really need to do right now is to decide what is that design going to look like, and then what are the ratios we're going to use for the wings with respect to the plane. And here I think what we really need right now is someone who's architecture who can actually do a good design and bring it up for us. Because we're just saying, if we continue as we're going to keep going around the same.
Yeah, that's what I said.
Somebody that was really good all the time or
I
something.
got to Steve,
Yeah.
I can handle it.
As I was saying, I told Joe the last time I should get the balsa wood. Like I said, the weight of the balsa wood will determine the design. Because you can't just come up with design and use a whole bunch of wood and all the way to be too much for the glider to go
So if we need the weight, then let's get that. Exactly. If we can get the wood.
Yeah, I told him the last time today. I assume we have them now, we'll be able to work on something.
Okay, Chinedu.
Alright, so you know what you say. The weight of the wood, right? Depending on the thickness, now we know what
How far?
So if we come up with a design and see what
Yeah, they come now, they come.
we want the design to be, then we can decide
Yeah.
what the weight is possible.
Right.
Then we can decide what issue should the wings be with respect to the project. Because really what determines how the plane takes off is the wings. No matter how fine the glider is, if the wings are messed up, you're not taking off anywhere. So what determines that is the wings. So if we have to sit down and decide, okay, this is the design we want, then based on that we say, okay, so this is the thickness of the wing. Then we go cut out the common measurements and set it up. And then we see, oh, this what is the ratio that can be. Then we decide,
Well, I think if
I don't know what the details are.
No, yeah, like a plane is huge and it still flies. You know, like I don't know that 1/4 an inch
Fly
or
through the force.
yeah.
A plane needs to be moving about 700 kilometers per hour to take off.
Yeah, I'm saying that I don't know that the thickness of the wood to a certain degree would hold us back from like
Okay.
determining the design or whatever.
Actually, there are many designs that we can go for. It all depends. We can make a slim body with big wings or just medium body, medium
So I'm
wings.
guessing we're going with 2 gliders, right?
No, we should
We
go
can
one
do it
gliders.
as many gliders as our budgets. Now we have $300 originally assigned for this budget.
About.
About $300.
Now we get the word.
Yeah, the reason why Chinedu is in charge is like conference planning check, so it's kind of knows how much we can do. But like our aim is $100 for everything we use. So this means that like if we have personal like equipment, personal things that we can donate, that would be great. We can use our pocket funds for certain things. That would also be great, right? So like I was trying to understand what you were saying about design. Can you please just you said we should agree on a design first and move on from there, right?
Because I think what we should, like, I mean, I agree that we have this. So the next thing, when we come, we know what we're talking about. We don't just keep talking about and asking questions. So what I was saying about the design is this. We can, this is from the side view now, right? We can have the body be something like this. And the rest, I mean, I'm not a very beautiful artist, right? So I mean, huh? Yeah. So, and then, I mean, this is where the wing is going or whatever. I'm not sure what the ratio should be, right? And then we have, like, from the top view, it's something really thin like this. Okay? So here it's pointed at the point at the nose, so it's streamlined. So when the air hits it, it spreads out like this. Okay? It's not like it's like a forcing thing. And then if the wings are here, tilted at an angle, when it gets to these wings, it goes under the wing and forces the plane to rise, the glider to rise. So that's the concept we're supposed to use. What talking about for the wing was this. They're supposed to be tilted at an angle of about between 5 and 15 degrees. This is the body here, alright? This is the horizontal. This should be between 5 and 15 degrees. Alright? I don't know what the optimum angle should be. That's why we have to need to get the professor on board who can like be like mentoring us now. We learn certain things about that. Then this thing. The 2 degrees I was talking about is this. Here you have how do I show it? Okay, here. It's already tilted at an angle of 15 degrees this way. Right, like it's tilted at an angle of 15 degrees with the horizontal now. Right, so take it and rotate it. And imagine that this is it now. The wing sticks out here. Okay, this is the wing here. Now you're going to tilt it from this point and tilt it about an angle of 2 degrees. So that the wing is slanted at this point and tilted here. So that when it hits, it's able to go on that well and then right. That's the concept behind it now. Again, at least that's how I look at that's how from what I did research on, that's what I understood from it. So I think at least we should start coming up with designs. I'm going to try and talk to Steve, who's the Aki guy, so that we can work on this and see what we can bring out. Alright? Then possibly if we can get maybe a professor on the aeronautic department to come to look at the design and like advance us like this and that and blah blah blah. That's why I think. And then I also think it's important that others like come up with their own different design. Let's see what works best, see what is achievable and what is feasible and what is not. Alright? So that was the design. It's not very beautiful, but
Can I add something? Yeah.
What I think is that talking about the stabilizer, I think the guys are something like you said, yes, it should be tilted and also within the price of the range. But the stabilizer should have something like on top of the leather like this. They should have like this.
At the tail?
Yeah, we should have drag will also acts this way. This is the lift, then weight, and this will be the drag. So this air, the wing air will help stabilize the whole flight process.
What shape is that?
but it's straight down.